Good evening, everyone. This is Dr. Polaiah, working as a professor in the Department of CSE, Data Science. It's a great pleasure to continue my video lectures with one more topic from our module number 1. As we are all now aware about our subject, that is image processing and analysis. So from this subject, we are going to discuss the one more topic which I am calling here steps in digital image system. So actually we know the one of the important point what we want to understand from here to select this topic steps in digital imaging system. So we are going to be detailed understand about this digital imaging system instead of digital image processing or digital image processing system, which we are going to say simply digital imaging system. So if you wanted to develop any type of digital image system, we have to prepare the certain steps. Being an engineering student, so we have to aware about different steps. Then the steps will help us towards to develop such a digital imaging system. So let me to go ahead with the help of this selected topic for the today video lecture, which we wanted to concentrate perfectly based on the agenda. So here the agenda again covers 4 topics. Number 1, of course, every day we are understanding first of all before we are going detailed information about a selected topic. Let we have certain understanding, simple understanding, that is introduction of the selected topic. And the second topic which is under this agenda is obviously though we are studying is outcome based education. This outcome education compulsory we have to understand and compare the course outcome with your selected objectives, course objective. So that means that mapping CO and PO and COs are mapping, we had to understand before that. That's what obviously we have to understand that the complete course which we are studying is outcome based education only. So from there we can understand from agenda second topic is comparing the course objective with the course outcome. That means how much your course outcome you are achieved. That mapping also we are going to see. And coming to the topic which you have selected today, that is steps in digital imaging system. So steps in digital imaging system, which is right now we are going to discuss in detail about this topic. And obviously once we understand such a systematical principles, then principles where we can apply. That is applications of that topic, especially in digital image processing, how it can be applied and how it may be go ahead. So those things we can understand at present. So coming to the this mapping is here, that is a topic learning outcome is simply as I've told you that the selected topic is steps in digital imaging system. That learning outcome 100% we are going to be gain the knowledge not only towards to understand this concept of digital imaging system, but also we are going to understand for achievement of such a course outcome in terms of fields of digital image processing fields of digital imaging system. So ultimately we may be going to understand that such a outcome in terms of steps that we are going to learn in a simple manner. Means of that, once we are understanding this topic, we are enabled to recall the concepts wherever it wanted to apply. So next, once we go understood this type of image processing, that is especially the steps in digital imaging system. If you want to prepare any digital imaging system like a camera, like a digital camera, it is a type of systematical system. It may be help us to convert your the photographer may wanted to keep that captured image into in black and white or color. That's decided by the your camera system process. That type of system, such means here such a camera system, being it is a digital image processing system, which we are going to be used, especially it works in terms of steps in digital imaging system only. So how it maybe works? Everyone may know, once if it says digital camera, then everyone may knows that yeah, it is obviously capturing the obviously capturing the images. And even that captured image, maybe you want to keep not only in 2D, two-dimensional image, but we want to keep in three-dimensional images. We can keep with the help of your captured camera. But that image, while you are keeping in terms of what we call either a 2D image point of view or a 3D image point of view, we are going to be keep that system in terms of work, such a digital image processing system, which is your required manner. So when we are processing such a images here, let me to show that first of all, the image which he captured, that will be sent here to the your camera. Okay, so this camera is right now I am calling as your digital image system. Instead of processing, I may call as here digital image system. So usually we may know digital image processing, but here instead of digital image processing, I call here digital image system. Why? Because being it is a system, okay, it converts your required process of the image into your record. So here we are going to decide that particularly this system will be focused on your keeping on to your required manner. For example, I kept here the focus on the especially I'm saying here focusing on the water trap. So say here, that means once we are focusing your image only at the part of water drop, then that type of part itself you wanted to show in terms of 3D, we can. So that means what you are understanding here, the captured image of the parts which we wanted to go ahead in terms of your required process, that means which you wanted to focus on the water drop by using your camera. So here camera is a digital imaging system. So this digital imaging system may going to be focused on the water drop of the image. So this is water drop. So this water drop from the image may focus on towards to using of your camera, in terms of zooming in such a way that the quality of the image remains the same. So that means you are supposed to be understand here. Supposed to be understand here is when we are going ahead with the help of such a digital imaging system, we can achieve our required process. Okay, so let me to introduce that. Actually, this is the figure which I am prepared for your understanding. Is this completely knowledge based? It is called knowledge based digital image system. Okay, so knowledge based digital imaging system, which is going to be covered here with the help of this block diagram. So what is this block diagram means? This is completely connected with the knowledge. Which knowledge? That is a camera, a technician or a technocrat who's concentrating here in terms of preparing such a knowledge-based system. Is here in terms of digital imaging system. Okay, so a technocrat who's preparing in terms of his knowledge-based digital imaging system may concentrate in terms of step by step. That means here we may consider one step is here, second step, third step, fourth, next, again next, again next, next, and finally you are going to be reached. So if you at all going in detail, step by step, so what is the use of that going? So that means he is based on his knowledge. A technocraft knowledge helps him to go for the requirement based only. So he is having step by step knowledge, obviously. But that steps of knowledge in terms of preparation of digital imaging system may going to be prepared based on the complete steps of the knowledge. So what I wanted to say here, very clear that if you wanted to prepare digital imaging system for particular application, we had to have the steps of knowledge in terms of digital imaging system. So steps in digital imaging system is here covers the here is the covers as much as fundamental topic only. So we'll see one by another. First we'll see the first step of this steps in digital image processing is image acquisition step. So you may going to understand this perfect digital imaging system that is here. We're going to keep one image here for the sake of understanding the fundamentals of steps in image processing. I'm going to be concentrated by taking one of the image, which is I called here a scan. What is it we call here? Some element based scanned image. So this scenery image we call simply scene element image. So this image, elemented image, which we are going to be sent through the system. This is system. Through the system. This is I called as system. Okay. So this system now you are keeping that in terms of image acquisition, then goes to your internal process of the image plane. So this is image plane. This is image plane. And you are going to get based on this system operated your output of the digital images. How we get? Let you see here. So image acquisition is the first step in digital imaging system. Okay. So this system modalities for getting the image into the computer. Enter into the computer system. Enter into the digital computer system. So now that the image is captured by a sensor, that nothing but a camera, and digitized if the output of the camera or a sensor, that is image sensor is not already in digital form, but using analog to digital converter in the digital imaging system, then we are able to convert an analog image data into digital image data. So that means the acquisition is here nothing but logging of the digital data. Logging of the digital data means purely we are going to see output in terms of digital image. Purely you are going to see in terms of digital image. So that digital image is here. We are going to be see in detail based on conversion of analog to digital converter. That is A to D converter. A to D converter. So later we are going to understand what is this converter, why they named as A to D converter, analog to digital converter, how it may play a vital role, especially in conversion of analog. That is analog image data is converting into digital image. Okay. So how we may understood this? So later we are going to understand this converter. But try to understand here, image acquisition means image logging process. So what it does? It's majorly concentrating the modalities for getting the image into the digitized computer image. So acquiring is processed in such a way. So how it may happen? As especially I said, when you are capturing image through sensor or camera. That camera right now may called digitized camera. That means it gives the output of the camera obviously in digital. And you are going to get that formation of output. If you want to convert output, that means here it will be processed. So that means depends upon your a digital imaging system may have this ADC converter internally, and it be processed. Then you're going to get your digital output. That is the process purpose we are using image acquisition. Next, coming to the second one is image enhancement. The attained digital image, you need to see, you may be getting this digital image, for example, such an image, okay, not be clear. It is maybe disturbed image, it may be blurred image, okay. Basically, it is not perfect visible. Then such an image we are going to convert it into enhancement image. So image enhancement, how can we do that? That is what we'll do with the help of simple steps which we call here image enhancement. Simply we call as image enhancement. This image enhancement process, especially let you see here, by processing of manipulating an image so that the result is suitably than the original specific applications. So we are going to be make that manipulating and that manipulating process of manipulating an image so that the result is more suitable than the original for specific applications. So especially you can understand here the idea behind enhancement technique is to bring out the details that are hidden or simple to highlight certain features of interest in an selected image. So an image which we are getting here enhanced, in terms of enhanced, is now a simple process in terms of process of manipulating of an image. Where we are concentrating here, we are concentrating especially the details that are hidden. That image may have certain content of the pixels are hidden. Make that or simple to highlight certain features of the interested in an image. Then that you may be going to get your required. You compare to these two image. Also this is basically image. Okay, this image right now enhanced. So this enhancement happen through this technique. Of course, how it may be happen, being an engineering student, we had to concentrate much more in detail later on. But now one of the step is here to understand as a second step in your steps in digital imaging system towards to concentrate image enhancement. So that image enhancement happen process of manipulating of an image, especially concentrated in terms of hidden or simple to highlight your certain features of interest in the same an image. Then you'll get the in terms of enhancement image. We'll see the third one, that is image restoration. Once you may get the image which is in terms of enhancement, may going to concentrate here image restoration process also. So what is that image restoration process? Here simply saying that improving the appearance of an image, that nothing but tend to mathematically or probabilistic models. How? That means the enhancement on the other hand is based on human objective preference, reading what constitutes a good enhancement result happen from a basic image to enhancement. So when we are concentrating such a constitution a good enhancement resulted image, it is a resulted image. This resultant image helps us the missing data also going to be keeping it here. How it may be improved? In terms of mathematically. The improving of the appearance of an image is in terms of mathematically or probability models based only, we'll get the restoration. Okay. So next we are going to see other type of steps. That is next step is morphological processing. That is here. Morphological processing here. So this morphological function processing is, again, I am taking the best example is our thumb impression image. So here we are going to read step by step by converting that image pixel intensities in the form of matrices, and we are going to apply some simple mathematics here and we'll get it. Let me to go with in detail about the morphological processing. Here, let you see here, tools for extracting image components that are useful in the representation and description of shape of the image. So in this step, there would be transition from process that output images to process that output image attributes. So what are the attributes are we are concentrating here? We are transmission. This process completely, this step is transmission from process that output images towards to process the output images attributes. Output image, but in terms of attributes. So what are those attributes? What are the attributes are helping to keep your image in terms of morphological process of an image? So that we are going to concentrate here. We compare to one to another image. This image we wanted to keep here. See, among these images here, you wanted to process that in terms of representation and the description of image, or description of image in terms of different shapes. You see here the shapes of the images. Okay, that process may keeping on in terms of shape into the your pixels. Then we are comparing your mathematical process. That is what we are saying here. That's what I said here. So the tools for extracting image components that are useful in the representation and description of shape of an image. That's called morphological processing. Next, we'll go ahead another steps in image processing that we called as segmentation process. Actually, it is one of the method in digital imaging processing. One of the method is called a segmentation method, segmentation process. So why we want to use this segmentation? Especially the image which we are considered here, okay, that image compared to one to another image of in terms of characteristics of an image. Let me go in detail about this image processing. You see here, I am taking the image. This image characteristics I am keeping here. Okay, so characteristics may helps us to understand what we know. Segmentation procedures partition an image into its constituent parts or objects. So that's the meaning of segmentation. Image segmentation means procedures partitions an image into its constituent parts or constituents object. That means you can understand this important tip here. The more accurate the segmentation, that means the more likely recognition is to succeed. I'll repeat, important tip. The more accurate the segmentation, the more likely recognition is to succeed. That is called image segmentation. That's what I can say. Image segmentation means procedure partitions an image into its constituents parts or constituents objects. What we want to keep an image into constituents parts. That is what constituent parts means, keeping an image into certain characteristics. Certain characteristics. You see these characteristics. So we are going to see the levels of the image and each and every pixels of the image. We don't want to concentrate the complete part of the image information, because the memory of the digital system may also concentrate here. Only the whatever the image which we are taking is here concentrating is only that parts of an image, that constituents parts of a particular image is concentrated here. In terms of memory space point of view, in terms of clarity, in terms of quality of the image, in terms of finding any noise of the image, in terms of missing data in the image. So for that, we are applying these steps. So of course, we have one of the chapter itself about this topic. There we are going to discuss in detail. Okay. Next, we'll go to another steps in digital imaging. That is object recognition. That is object recognition. So here object recognition, which is right now we want to understand here is object recognition. So very important steps this section. So of course you by taking an image, that image characteristics immediately you have to find for the sake of object recognition. We'll see that. Let you see here. You see object recognition. Okay. So you are going to find from this image certain number only. You want to find from this vehicle only that letters. So from this image which is not visibility. What is this image front view? That vehicle front view, not visible. But we can see that in terms of recognition. Then what is the definition of object recognition of an image is used to define in terms of the process that assigns label to an object based on the information provided by the description of an particular image. So that is here. It is a process. Being it is a steps in digital imaging process, but this whenever you select that separate processing button as the object description process, then once you press that, immediately it processes that assigns a label to an object on the information provided by its description. So recognition is the process that assigns a label such as vehicle. What is your label here? Is vehicle. To an object based its description. So this object based descriptions right now we are going to give in terms of, for example, let me to provide you the process of an image which in terms of labeling we process the objective. We process the objective recognition. Let me to give the best example is here. By taking the image here, okay. So what is the label here? Car number. So car having 100% number. So this number not able to visible at certain issues, at certain incidents or certain accidents. Being it is on the road, the vehicles are going one to another. May have this vehicle and this vehicle may have some problems together. Then we wanted to see that in detail. So for that, what we had to do, proceed with the help of your digital image processing, So we can proceed that in terms of one of the major steps which we can use, step number 6. Okay, step number 6 is simply we say object recognition. So here we can proceed that and we find simply. Detailedly we can understand what is the mathematical tool, which type of imaging processing tool we are using in this aspect, being it is a part of digital imaging system, and we can find that kind of process. Okay. So we'll going another step that we called as representation and description of an image. So what is an image? Okay, an image which we are going to keep into the representation and description. So how we represent this and how we make into the description. We'll see in detail. Okay. So here that is last step, that is seventh one. Okay, representation and description. So first of all, you have to understand what does it mean representation of an image. Being it is a part of digital imaging processing step, how it may be concentrate such a one is simply we can say make a decision whether the data should be represented as a boundary or as a complete region. It is almost always follows the output of a segment stage. So that means, what does it mean here? Always follows the segmentation stage, in the sense boundary representation means is here focus on external shape characteristics such as corners and inflections. So what do you mean that? So we are going to understand representation means only in terms of one is boundary process, another one is completely reason. Either one. So let us be understood first of all boundary representation. Boundary representation means it is focused on external shape characteristics of an particular image such that in terms of corners and inflections. If you go to the second part, that is second way we are going to be convey your representation is here region representation. It is concentrate internal properties of an image such as in terms of structure or in terms of skeleton shapes of the particular image. So based on this, we are going to be defined in terms of region representation. Based on external shape of characteristics, we define in terms of boundary representation. So that is very important here. So we are going to see in terms of here taking an image here. What do you mean taking an image? Taking in terms of that image, what you say is that external representation, external characteristics representation of an image shape. So this is the shape, external shape. Okay. So no, we are not concentrating internally. We are concentrating only external. That too we are keeping in terms of characteristics. See, is the we call as boundary representation. When we going ahead in terms of internal, we are going to be see one by another of a particular image of the characteristics pixel to another pixel. Internal process. You see here, we are keeping that internal and external differences. That means transforming the raw data into form suitable for a subsequent computing processing. Description deals with extracting the attributes that result in some qualitative information. Description deals with extracting attributes that results in some quantitative. Previously I said not qualitative. It's not qualitative. It is compulsory concentrating on some quantitative information of interest or basic for differentiating one class of object from another. So you see here, description deals with extracting attributes that results in some quantitative information of interest or the basic for differentiating one class of objects from another object. So one to another. So this is what we are going to say. This is completely seventh steps in digital imaging process. Of course, we are going to see in detail all the steps one by another in as per our syllabus, because these all steps are helps us to cover all 5 modules of the syllabus only. Let me see the one more one is here, that is image compression. It is another fundamental steps in digital image processing or digital imaging system is image capturing. Sorry, image compression. So what does it mean image compression here? That is 8th step. So image compression is here. It is a technique for reducing the storage required to save an image or bandwidth required to transmit it. So you see here, one image to another, one image to another. Storage capacity of the sizes are changes here. So we modifying one file to another in terms of storages. So what do you mean this? So image compression is also one of the steps in digital imaging processing in terms of digital imaging system for the convenience of your image transmitting. That is, it is a technique for reducing the storage required to save an image or the bandwidth required to transmit it. So that's what we are going to use. It is one of the steps in digital imaging system. So we'll see the last but not least, that is color image processing. So far you may be concentrated maybe gray level image processing or that image characteristics point of view, but now it is came from the gray level into color image processing. So once you may be taking such an image and make this image into coloring process. See, it's easy because we are going to see in detail as one of the steps in digital imaging system. It concentrates towards to in terms of colors. Basically, you know the RBY, that is red, blue and yellow. So RBY colors are now help us to prepare basic colors. You see red, yellow and blue. So what are these? These are the colors are help us to convert any gray level image into how it may be see here. So color image processing is use the color of the image to extract the features of interest in an image. So that means color modeling and processing in a digital domain is also concentrating for your required level. So that's what we cover, converting this one image to another. So what we want to understand from here, based on your understanding such a color imaging processing is right now extended to another step that is called multi-resolutions analysis using wavelets of the images. So what is this? This is the foundation of representing images in various degrees of resolutions. It is used for image data compression where images are subdivided in smaller regions. So multi-resolution analysis is a different approach of signal processing that gives coarses as well as detailed information at the same time with effect extension of MRA, which resolves signals in the domain that is best suitable for analysis. That means WT is the gives more information than FT and also computationally efficient. So WT is here nothing but wavelet transforms. Wavelet transform right now compared to Fourier transform, that processing is here helps in terms of multi-resolution process. So that is wavelet transform compared to the Fourier transform. Okay. So here Fourier transform is in continuous, but here not in continuation process of the transmission. It is subdivided process. So that's what it gives more information than FT, and also it gives the computational efficiency of the information. So of course we understood so far the complete 10 steps in digital imaging processing or steps in digital imaging is concentrating applications point of view also. Number one, digital medical image process. That simply I called as biomedical image digital, especially it is digital image processing. And also it is used in terms of quality controls surveillances. Quality control surveillance system. I am combining both. How can I combine both application together? Is by the help of my 10 steps in digital imaging processing, I can do it. And we can concentrate on law enforcement in terms of digital image system. How it is? Because I'm having the knowledge in terms of law enforcement. So that means here my today topic is also knowledge based digital imaging system I'm designed. Digital imaging system I'm designed with the help of 10 steps. For whom? For the application of law enforcement. Of course, we are not discussed how we developed, how we designed that 10 steps. We may going to have complete descriptions later on based on our modules of the topics information discussion time, or that modules of topic one to another help us to design or to develop such a law enforcement. Not only law enforcement application point of view, that 10 steps in digital imaging system may also concentrate artistic effects application point of view also. So with this, I'm concluding with the first reference only, which I'm discussed so far. With the help of these references, I'm concluding right now. Of course, I'm very happy about you all towards to concentrated our discussion from first slide to up to right now. I'm very thankful to one another. Of course, if you have any other doubts, so we'll discuss later on. With this, I'm concluding and I'm stopping my discussion. Thank you so much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.